This is my another linear algebra videos where I'll just try to explain you today how to identify if a matrix is linearly dependent or independent. There are a couple of conditions to meet to identify if a matrix is linearly dependent or independent. So in this video, I'll just try to summarize those conditions as efficiently as possible to for you to understand it easily with some examples. First of all, a set of vectors or a set of one vector is linearly independent if it is not a zero vector. What does it mean? It means, suppose you have a vector like a can be a number, and if you multiply and you can solve for this vector, that is independent. But if you have a and the vectors are 0, 0, 0, right? For example, I take 5 is as a and you have 0 vectors there. And if you solve it, you're getting zeros. That is dependent. Okay, that's condition 1. Now, second condition, you can test a set of two vectors is independent if they're not multiple of each other. What does it mean? Like if you have a vector 2, minus 1, and 3, and you have another vector with 1, 2, and minus 1, they are independent because they are not multiple of each other. But if you have the vector 2, minus 1, and 3, and you have another vector which is 4, minus 2, and 6, this is the multiple of this vector, the previous vector. If you multiply each of them by 2, you get this thing done. You get the second vector. So this vector is a multiple of the another vector. So this is actually a dependent vector. Now, another condition of finding if it is independent or dependent is a set of vector is dependent if the number of vectors is greater than n. Like you can say if a set of n times one vector is, like you take the m1, if the vector is greater than n. For example, if you have a vector 1, 2, and 1, another vector 0, 3, 1, 2, and 1, minus 1, and 0. Suppose these are your set of vectors, which is like column 1 and 3 rows. These vectors, this set of vector is dependent. Why? Because it is 3-1 vector, 3-1 matrix. Like it has 3 rows and 1 column, each of them. So it is a 3-1 matrix, and but there are 4 vectors. So the total vector number, the total matrix are actually more than their number of the rows. So the condition was n times m vector is independent if this is the set of the vectors independent if their total number of matrix is greater than their rows, individual rows. So you have the 3 rows here, but you have the 4 vectors, so it is like a independent vector. Now another condition is, I'm saying it is a dependent vector, sorry. Now another condition is a set of containing zeros, I mean 0 vectors, is always dependent. Like if you have a set of containing 0 vector, that is always dependent. Now, another condition to identify if a vector is dependent or independent is if the set of vector only contains distinct unit vectors, it is independent. For example, you have 1 0 0, you have 0 1 0, and you have 0 0 1, or you can say it is 1 0 0 0 1 0 0 0 1. This is independent. Okay. All right, let's go to the next condition, which is if the determinant of a matrix is 0, then it is dependent, linearly dependent. And if determinant of the matrix is not 0, it is independent. So this is about the determinant. You need to find the determinant, check if the determinant is 0 or the determinant is more than 0. Now, another way you can identify the matrix is dependent or independent is after you complete, when you have the matrix, and if you just get the row echelon from the vector. So after getting row echelon form, hope you know how to find the row echelon form of a matrix. If you don't know, then you need to just know it, and you need to find the row echelon form of the vectors. So if the row echelon form of vectors is, suppose x1, x2, x3 up to xn equals to 0, it is independent. And if one of them x values, if one of them is not 0, it is dependent. For example, suppose you got the row echelon form of some matrix, and you got this, then it is independent because you have x1, x2, and x3 equals to 0. But if you have if you get matrix, the rotational form of the matrix in this form, which is this, here it is dependent because your x3 is suppose a t, your x2 is negative 3t, and your x1 is negative 2t, right? So you don't have x1, x2, and x3 is 0. So that's the reason it is dependent. Okay, so this is the first part of my video to identify if it is if a matrix is linearly dependent or independent. Check out my second part where I'll explain you more of this linear dependence and independency. Thank you very much.